Alright, so we're just going to do a review of different properties and definitions just to make it easier in case you forgot these, or you're like, Mrs. Curry, you mentioned a whole bunch of stuff and I don't ever remember hearing that. Well, this is our chance of refreshing. So, addition property of equality, we talked about this when we talked about solving equations. This is where we add to both sides equally. Subtraction property of equality is when we subtract from both sides equally. No, don't do that to me. A multiplication property of equality is when we multiply both sides equally. That's where the equality comes from. And division is when we divide now, so that was stuff we definitely went over. For Math 8 it was chapter, actually I think for both classes it's chapter 2, but definitely when we talked about solving equations. These other ones are items you've talked about in some way or another, probably in elementary school. This first one's the associative property, and this is when we're moving parentheses. So if I have A plus B plus C, that is equal to A plus B and then plus C. So we can move our parentheses. I can do that for both addition and multiplication. So I could have A times B times C is equal to AB times C. And so that's the associative property. We're moving our parentheses. And then we have the commutative. That's where we're changing the order. So if I have A plus B, that is going to be equal to B plus A. Or with multiplication, A times B is equal to B times A. So that we're saying it doesn't matter which order we add or multiply in, we're going to get the same answer. The identity property is A plus 0 equals itself, or A times 1 equals itself. We're seeing our identity. It's like looking in a mirror, we see ourselves. The inverse property is what gets us to 0 or 1. So when an inverse is like A plus negative A, right? We're doing an inverse operation. That gives us 0. When multiplying, that would be A times 1 over A, because that equals 1. So like multiplication, if we had 2/3, the inverse would be 3/2, because then I get 1 for my answer. Distributive property, we've definitely done that one before. That's when we have A times B plus C, and we distribute equally, so we would get AB plus AC, because we multiply the A to both. Now, the transitive property, that's the one we talked about in our last proof. So what that is if A equals B and B equals C, then A equals C. And we can have like that. It's like making a train. Think transitive train. We're taking A was equal to B, but B is also equal to C. Therefore, they're equal to each other. A is equal to C. And we could have that several times. I could have A is equal to B, and B is equal to C, and C is equal to all the way up to Z if you wanted to, and then we could say that A was equal to Z. Either way, it's creating that train of equality. All right, and then the symmetric property is similar to the commutative, but it's flipping what side of the equal sign we're on. So if A equals B, then B equals A. So kind of like when we write x equals 3, or the fact that 3 equals x, it's the same thing. All right, and then last one, the substitution property. This is where we replace. And we've used this one several times when we were just using substitution with expressions. Some of us have used it to solve a system of equations. So substitution property is used quite often if we want to check our answer. So if I tell you that x equals 4 and give you 2x minus 3, then no. I hate when that happens. All right, then go right. We would have 2 times 4 minus 3, and then you would solve it. But that's showing that replacing. All right, so those are a list of properties, things that we know. Now, some list of definitions, postulates, and theorems that we've already used. Supplementary angles add up to, is that 2 angles that add to 180 degrees. Complementary angles are 2 angles that add to 90 degrees. Remember, complements are always right. Angle addition postulate is small plus small equals the big angle. Right? Angle plus angle equals big angle. Alternate interior angles theorem, that is that our alternate interior angles are congruent. Corresponding angles theorem, if we have the parallel lines, then the corresponding angles are congruent. Now, midpoint, this is in your study plans, it's not in your homework, but a midpoint is the middle of a segment. And so if it's in the middle of a segment, that means that each side is equal. So if I gave you, say, a segment, and I told you that one side was 3x and the other side was, I don't know, 4x, right? Nope. Yeah, 4x, hold on. 3x and 4x. Let's do plus 3x plus 1. All right. If I am given that m is the midpoint, then 3x plus 1 equals 4x. And then we would solve. So I'd subtract the 3x from both sides. So I have 1 equals x. So x equals 1. And I could solve. But that's what a midpoint is. It's just that it's the middle, so then on either side, they are equal. And when you get to that in your study plan, and if you need help with that, ask. I'm happy to help, but I wanted you to know that one. It is one that you will use a lot in geometry class when you get to geometry, but it is definitely in your study plans. So